Hi, this is Leo and Jason, and we're doing the chemistry summative on internal combustion engine and gas-powered automobiles. These are parts of internal combustion engine. The first one is cylinder block. It is located in the bore of a cylinder, where the air-fuel mixture is located and ignite. It creates a powerful combustion force to compress and expand to give power to the piston.
The second one is cylinder head. It carries inlet and exhaust valve. Fresh charge is admitted through inlet valve and burnt gases are exhausted from the exhaust valve.
Third one is piston. Piston sucks the fresh charge of air-fuel mixture through the inlet valve and compresses during the compression stroke inside the cylinder. This way, piston receives power from the expanding gas after ignition in cylinder. Also, the force of burst exhaust gas out of the cylinder through exhaust valve.
Piston rings. It prevents the compressed charge of fuel air mixture from leaking to other side of the piston. Oil rings is used for removing lubrication oil from the cylinder after lubrication. This ring prevents excess oil to mix with charge.
Inlet valve and exhaust valve. Inlet valve allows fresh charge of air-fuel mixture to enter the cylinder bore. Exhaust valve permits the burst gas to escape from cylinder bore at proper timing.
Fuel pump. The device supplies the petrol to carburetor, sucking from the fuel tank.
Spark plug is used in petrol engines and it ignites the charge of fuel for combustion purposes.
Fuel injector is a device that is used in diesel engine only and delivers fuel in fine spray under pressure. 6 connections. The first connection is combustion involves a fuel occurs with an oxidizer in the combustion chamber. Using Le Chatelier's principle, we can change the force applied to the car by changing the amount of air or fuel combusting.
The second one is gasoline engine ignition system, generally rely on a combination of a lead acid battery and an industrial coil to provide a high voltage electric sparks to ignite the air fuel mix in the cylinder. This is related to what we are learning now, the batteries and electrical energy.
Third one is all internal combustion engines depend on the exothermic chemical process of combustion. The reaction of a fuel typically with oxygen from the air. Using Le Chatelier's principle, we can adjust the heat by adding the coolant to make the car more efficient.
The fourth one is nitrous oxide, or it is as we know it, nitro. It is used in car to help it perform better, as nitrous oxide being pushed into the engine, it helps breaking the air into particles of oxygens. It makes the temperature of the engine decrease, therefore the performance of the engine will increase.
Fifth one is the engine compresses the fuel and the air into the enclosed system and ignites it. Using Le Chatelier's principle, we can know that this is efficient because the reaction leans to the right side, the product side, due to the high pressure and the smaller volume.
And the last one, it's fuel powered cars versus electric powered cars. Each of them have their own advantage and disadvantage. First connection, combustion and combustion chamber. This picture located over here, it's the combustion chamber. As you can see, the red and the blue are where the fuel and air is going in. The piston here, it's where the fuel air mixture explodes, releasing combustion energy. The combustion energy then pushes the shaft out, turning the wheel over here to start the engine and make the car move. The spark plug emits a spark to ignite the gasoline. It is a fuel air mixture where, since there's oxygen in it, it is explosive. This liquid is located in the combustion chamber. The gasoline charge in the cylinder explodes because this is a explosive material. As it explodes, it gives energy to start the engine, where it pushes the piston and moves the car.
From the chemical equation, we know that methane reacts with oxygen to create carbon dioxide, water, and explosive energy, and this energy is used to move the piston to move the car. Therefore, by changing the amount of fuel and the air added to the car, we can change the energy releases to the car.
The second connection is battery-powered spark plug. It is the S located on this picture.
It's a fuel cell. It's acting like a galvanic cell before the engine starts. It ignites the fuel to start the engine. When the engine is turned on, the battery is recharged by the alternator, acting like an electrolytic cell. The extra electrons added to the battery move the the reaction backward. The anode reaction is lead sulfate solid plus hydrogen ions plus 2 electrons, creating lead solid plus hydrogen sulfate. The cathode reaction is lead sulfate plus water equals to lead oxide plus hydrogen sulfate plus hydrogen ions plus 2 electrons. The extra electrons added by the alternator reverse the reaction, changing the lead sulfate to lead and lead oxide. Therefore, the reactor is back to where it was, and the galvanic cell can be used again.
The third connection is inlet valve and exhaust valve. And this picture is showing where the mouse is. This is the inlet valve or the intake valve, and this is the exhaust valve. The spark plug is located in the center, and this big chunk of thing here is the piston.
The inlet valve lowers when the engine starts to let the cool air comes in to lower the temperature and goes back on to lock the air inside. And after the reaction happened in the combustion chamber, the exhaust valve lowers to let the hot air goes out to lower the temperature inside the combustion chamber and goes back on to be ready for the next cycle.
According to Le Chatelier's principle, the exothermic reaction leans towards the right side during lower temperature and leans towards the left side during higher temperature. The fourth connection is the use of nitrous oxide, as we know it NOS or nitrous. The nitrous oxide, it breaks the air, allowing more oxygen in the combustion chamber. By doing so, it cools down the air that's going into the combustion chamber to lower the temperature of the engine. Nitrous oxide is not flammable at lower temperature or pressure. It is actually a gas, but because it's so compressed, it's actually a liquid for easy storage. The fifth connection is pressure in combustion chamber.
The engine compresses the fuel when it's rotating, and the air inside and the fuel inside the chamber is being compressed. Therefore, the volume and the pressure increases as the result.
Due to the Le Chatelier's principle, because of this reaction, due to pressure and volume, more products will come out.
The fuel and the air are almost compressed into solid form, meaning that the more energy will be released when changing to the gaseous form because the change in the volume is too big that it pushes the piston larger forward to move the car. Last connection is the fuel power car versus the electrical power car. The electrical power car is more expensive in terms of the car, and the fuel power car is more expensive in terms of the fuel. The electric power car cannot change the efficiency, but is fairly efficient in terms of changing the energy to the connected energy. For fuel power car, it can change the state of the fuel, the temperature, the volume, the pressure, and the amount of the fuel and air that to change the efficiency to give the car a boost. But it's not so efficient in terms of changing energy to connect the energy. Fuel powered car is polluting the atmosphere, while the electric car is a little better for the environment. Electric power car takes a long time to recharge, however, and can only travel a very short distance comparing to the fuel car, which can travel a long distance with a little time to refuel.
Begin illustrating the mechanical components in the internal combustion engine. We're going to start with the piston. The piston is a mechanical device that slides up and down inside the combustion chamber, bringing fuel and air during its first cycle into the combustion chamber, compressing it during its compression cycle, and it's what's used to convert the chemical energy into mechanical energy.